Welcome back once again. Today we shall look at calcium and its compounds. We know that calcium is an element of group 2 of the periodic table, where we have just looked at one of the elements of the periodic table, that is magnesium and its compounds. So right about now we are going to look at calcium and its compounds. So let us look at calcium. Calcium, this is an abundant It is abundant in earth crust and essential for living organisms. Calcium is, in the presence of vitamin D, plays a big role in building stronger and denser bonds early in the lives of the humans and other animals. Has a melting point of 1115 K, gives off a red flame when ignited. So properties of calcium: it is abundant in earth crust and it is essential for living organisms. And then calcium, in the presence of vitamin D, plays a big role in building stronger and denser bonds early in the lives of humans and other animals apart from humans. And then calcium has a melting point and gives off a red flame when ignited. That's briefly what you need to know about magnesium. Just like how we looked at the sources of magnesium, calcium as well has natural sources, since we can easily find them on earth crust. On earth, or in the earth. Yes, we can say in the earth. So we have a number of sources of calcium. One is lime water, we have chalk, we have marble, we have gypsum, and then phosphorite. So this is a chemical symbol. We can say this is hydrated calcium sulfate having two molecules of water of hydrolyzation. And then this is our calcium phosphates. We know that phosphates have a valency of 3, that's why we are having 3 here, and calcium has a valency of 2, and that 2 goes to this other side. And we have put this bracket to indicate that this 2 is affecting both letter P, which is phosphorus, and O, which is oxygen, making phosphate. So this phosphorite is a mixture of calcium and a phosphate, giving us this, and this is a mineral where we can find calcium. So these are 5 sources of calcium. Physical roles of calcium, physiological roles of calcium. Calcium is essential in muscle contraction, essential component in building strong teeth, bones, nerves, and muscles, essential in bone formation and blood coagulation, important in nerve impulse transmission, regulation of heartbeat in the human body, and then also in electrolytic balance in the human body. So we need to appreciate the need to have a regular heartbeat. We also need to appreciate the need to know how the nerve impulse is transmitted across the synapse. And then we also need to appreciate electrolytic balance in the human body, and we shall be able to know why calcium is very vital element in the human body as well as other animals or living organisms. So I repeat again: physiological roles of calcium: essential in muscle contraction, essential component in building strong teeth, bones, nerves, and muscles, essential in bone formation and bone coagulation, important in nerve impulse transmission, regulation of heartbeat in human body, electrolytic balance in human body. Those are physiological roles of calcium. Calcium compounds. Calcium compounds used in medicine include calcium oxide, that is burnt lime, calcium sulfate, that is burnt gypsum, precipitated calcium carbonate, that is chalk, that we talked about up on the previous slide, okay, as a source. And then we have calcium chloride and calcium gluconate. So calcium chloride, calcium gluconate, precipitated calcium carbonate, calcium sulfate, and calcium oxide are some of the compounds of calcium that you don't have to forget. So let us see one compound of calcium, that is calcium chloride. And our main interest is to see or to prepare our calcium chloride. Calcium chloride is produced by reacting calcium carbonate with hydrochloric acid. Calcium chloride is a salt. We need to react a carbonate. All carbonates react with the acids to give us carbon dioxide gas and water. So what you need to know at the back of your mind, when carbonates react with acid, we expect to evolve a carbon dioxide gas. That is the first thing we need to know. So calcium chloride is produced by reacting calcium carbonate with hydrochloric acid solution, producing sodium chloride, water, and carbon dioxide. Calcium chloride undergoes crystallization, producing hydrated calcium crystals. So the first thing we form, okay, what you need to have in mind, what are the reagents we are going to have and which products are formed. The reagents we're having calcium carbonate and then hydrochloric acid. So what are we forming? We are forming calcium chloride, water, and carbon dioxide gas. And we can also be asked to write equation of reaction between calcium carbonate and hydrochloric acid. And then afterwards, we are asked to identify the gas evolved. So as we talked about how we can identify carbon dioxide gas in the previous lectures, we say that carbon dioxide gas can be identified using lime, or we can say lime water. And lime water has a chemical name that we call calcium hydroxide. So we see that this carbon dioxide gas, we pass it through calcium hydroxide. So when we pass our carbon dioxide gas through calcium hydroxide, we expect to see a turbid solution if whatever we have passed in calcium hydroxide is indeed carbon dioxide gas. If it is not, we shall not see a turbid solution. This turbid solution, other people see it as a cloudy solution. It is all the same. And then some people call it a whitish, maybe smoke, something like that. Yeah, people may observe differently and they have different ways of making conclusions. So when you say anything like turbidity or cloudy, you will have to conclude that carbon dioxide gas has been evolved. So this is our chemical equation of reaction. This is what happens and this is how it looks like. Make sure that you balance them and make sure that any equation that you write has states. So this is a solid state, this is aqueous, this is liquid, and this is a gaseous state. So after we have formed this, we need to hydrate it for us to get a water of hydrolyzation. And here specifically we are having 6 molecules of water of hydrolyzation. So let's look at properties of calcium chloride. Properties of calcium chloride that we have formed, that is a hydrated calcium chloride. Calcium chloride that contains water of hydrolyzation. Calcium chloride is a colorless prismatic crystals with bitter salt taste. Dissolves readily in water, dissolves readily in alcohol, that is 95% alcohol, and then it is a hygroscopic. So let's see why we need to study all this about. We look at the uses of calcium chloride. Is used in hemostatic agents in gastric, pulmonary, and uterine hemorrhage, improves blood coagulation during surgery, used to eliminate itching in allergic diseases, and then used as an antidote in magnesium salt poisoning. So that takes us to identification test for calcium chloride. How do we identify for the presence of calcium ions? So whenever you are asked to carry out identification test, look at your compound. Does it have two ions? Does it form two ions when it completely dissociates in water? So we see that calcium chloride will completely dissociate to give us calcium ions and chloride ions. So here we carry out a test for calcium ions alone. So these are cations because it has a cat, and then these are anions because it has this minus sign, and this is a plus sign. So you identify each salt, not each salt, but each ion separately. So we start with cation, that is calcium ions. Calcium ions, we need to use a reagent, and a reagent that we use to confirm for the presence of calcium ions is ammonium oxalate. And then our observation, if calcium ions is present, we expect to observe a white precipitate formed, and when dissolved in mineral acid, it is dissolved. We can say a white precipitate soluble in mineral acids. And we know that we have three types of mineral acids. We have sulfuric acid, we have hydrochloric acid, and we have nitric acid. And when we look at oxalate, this is a salt derived from carboxylic acid. Okay, so we see that this white precipitate, when formed, we expect it to dissolve in mineral acids or strong acids if calcium ions are present. If they are absent, because when you are giving your answer, you have to give us a two-way answer, when it is absent and when it is present. If calcium ions are absent, we do not have any observation, so we shall say no observable change. A colorless solution remained colorless. A colorless solution of calcium chloride remained colorless, or we can say there was no observable change, and our conclusion will be calcium ions absent. For this case, when a white precipitate that dissolves in mineral acids, we shall conclude and say calcium ions confirmed present. And then for chloride ions, we need silver nitrate in the presence of nitric acid. Our observation is a white precipitate. So it's the same thing. For silver nitrate, we have looked at it right from group 7 elements, because in group 7 we still identify this ion. And for us also to confirm this ion, we said when we react silver nitrate in the presence of nitric acid, we expect a white precipitate. But this white precipitate that we have formed is soluble in both ammonium hydroxide and ammonium carbonate. So when you add ammonium carbonate to this white precipitate, we expect to see a colorless solution. We expect this white precipitate to dissolve in ammonium carbonate, as well as it dissolving in ammonium hydroxide or ammonium solution. When that happens, we confirm a presence of chloride ions. We don't just stop here. I have stopped here because we have already discussed about this in group 7 elements of the periodic table and their compound. So that is how we confirm for the presence. And if we add silver nitrate in the presence of nitric acid and we have no observable change, the solution remains colorless, we shall say chloride ions are absent. Thank you for watching calcium and its compounds. So this is what we have looked at today. We have looked at calcium itself. We have looked at the physiological roles of calcium. We have looked at the different compounds of calcium, where we have picked interest with calcium chloride. So we have prepared the calcium chloride from a carbonate, and most preferably calcium carbonate, by reacting this carbonate with an acid. And the most preferred acid that we took was our hydrochloric acid, giving us calcium chloride, water, and carbon dioxide gas. So we say that this calcium chloride formed can be hydrated for us to have water hydrolyzation. And after it has been hydrolyzed or hydrolyzed, hydrolysis, we expect to have water hydrolyzation, or a hydrated calcium chloride is formed. So after that, we looked at what are some of the uses of this calcium chloride, why do we need to learn about it, and then we have just summarized with identification test of calcium, as well as identification test of chloride ions. So wherever you will find a compound having calcium ions, please use ammonium oxalate to test for the presence of calcium ions. And if it is any other anion apart from chlorine, you should also be in position to know which reagent is used to test for that specific compound. Otherwise, thank you so much for listening. Do not forget to subscribe and stay tuned for barium and its compound as another element of group 2 of the periodic table.